Good day everyone, I am Annalyn B. De La Cruz and today I am going to discuss subgroup which are cyclic subgroup. So again, here is our subgroup and we already discussed it in the task number 2. So now we will explore and check which subgroup are the cyclic subgroup. So let's check the given condition. To classify whether a subgroup is cyclic subgroup, we need to satisfy the given condition. So the first one is the subgroup must be an abelian. Number 2, it must have at least one generator. When we say generator, it is an element that generates all the elements of the set. So let's start with our improper subgroup. So we can classify if the table is abelian if the elements on the table are symmetric from its diagonal. So as you can see, the encircle which are 2 and 4 are not symmetric from its diagonal. Therefore, we conclude that it is not abelian since being abelian is one of the conditions fails to satisfy. Therefore, this subgroup is not a cyclic. Now let's proceed to our proper subgroups. So let's start with our A sub 2. So since the elements are symmetric from its diagonal, therefore it is an abelian. So let's check its generator. D is D, R, E, A, M, I, N, G, D, R, E, M, N, D, E, A, N, R, M, G, E, I, D, A, M, D, M, I, E, G, M, R, N, A, D, I, and N, M, D, M, E, D, N, and lastly G, N, I, M, A, E, R, D, G. So our generator here is R, A, or the generator here is R, A, I, G. This is our generator because it generates all the elements. And since it is abelian and has generator, therefore this subgroup is a cyclic subgroup. Next we have A sub 3. So as you can see, the encircled elements are not symmetric from its diagonal. Therefore, it is not abelian. Since one of the conditions fails, we can conclude that this subgroup is not a cyclic. Next, we have A sub 4. So as you can see, 8 and 4 are not symmetric from its diagonal. Therefore, it is not abelian. And since it fails the condition as being abelian, therefore this subgroup is not a cyclic. Next, we have A sub 5. As we can see, the elements are symmetric from its diagonal. Therefore, it is abelian. So, let's check the generator. D is equal to D. M is dm. 1 is 1D. 5 is D5. So, as you can see, there is no generator. So, even though it is abelian, it has no generator. Therefore, we can conclude that this subgroup is not cyclic because it fails the condition of having at least one generator. Next, we have A sub 6. As we can see, the elements are symmetric from its diagonal, so it is abelian. Next, let's check the generator. D is D. 3 is D3. M is DM. 6 is D6. So it has no generator. Since it is abelian but has no generator, therefore this subgroup is not cyclic. Next, we have A sub 7. So the elements are symmetric from its diagonal. So this is abelian. So let's check the generator. D is D, 2 is D2, M is DM, and 7 is D7. So as you can see, it has no generator. Therefore, this subgroup is not a cyclic subgroup. Next, we have a sub-8. As you can see, the elements are symmetric from its diagonal. So this is abelian. Let's check the generator. D is D, M is DM. So our generator here is 1 since it is abelian and has generator. Therefore, this subgroup is a cyclic subgroup. Next, we have a sub-9. It is abelian because the elements are symmetric from its diagonal. So let's check the generator. D is D, 1 is D, D1. So it has generator which is 1. So since it satisfied all the condition, therefore it is a cyclic subgroup. Next, we have a sub-10. So as you can see, it is symmetric from its diagonal. So it is abelian and it has generator which is 3. Next, we have a sub-11. So as you can see, it is abelian and it has a generator of 7. Next, we have a sub-12. It is abelian and has generator. Next, we have a sub-13. As you can see, it is symmetric from its diagonal. So this is abelian and it has generator which is 6. So therefore, it is a cyclic subgroup. Next, we have a sub-14. So as you can see, it is abelian. It has generator which is 2. So therefore, it is a cyclic subgroup. Next, our trivial subgroup for the A sub-15. We all know it is abelian and has generator, so this is a cyclic subgroup. So here is the list of subgroups that are cyclic subgroups. We have A sub-2, A sub-8, A sub-9, A sub-10, A sub-11, A sub-12, A sub-13, A sub-14, and lastly A sub-15. So next, we need to determine whether the group is cyclic or not. So as you can see, the encircled elements are not symmetric from its diagonal. Therefore, it is not abelian. So let's check the generator. D is D, R is E, A, M, I, N, G, D, and R. Next is E. We have M, N, D, E. Next we have A, N, R, M, G, E, I, D, A. And next we have M, and so on and so forth. So as you can see, it has no generator. Since it is not abelian, it has no generator. Therefore, we conclude that this group is not a cyclic subgroup. That's all for today. Thank you for listening. I hope you learned something. Goodbye!